Hello everyone, welcome to AI Anytime channel. In today's video, we are going to create a Streamlit application to summarize documents. And this application will be powered by a language model called LaMini Flan T5 248 million parameters that we have. So we are going to use a language model in this video to see if we can summarize the documents. And this is completely an open source model. We are not going to rely on OpenAI here. We do not need any kind of API keys to build this application. So we are going to use this language model, which is not that large. So we are living in the era of large language models, okay, where you would have seen models like Llama, Alpaca, Dolly, etc. have been released by different organizations and research group, and those are all open source models. Of course, the licenses are different, to use that for development of commercial purposes. So in this video, we are going to rely on LaMini Flan T5, okay, which is not that large, have around 248 million parameters, and that's what we are going to see. It's fine-tuned on Flan T5, which is a language model by Google again. Flan T5 is a very underrated language model, okay, in the community. It's extremely underrated, okay, a model which was released by Google a few years ago, and this is fine-tuned model LaMini. We are going to use that, and it has couple of pipelines that I am familiar with. One of the pipeline is summarization pipeline. The other pipeline is also had a text generation pipeline. So we are going to use the summarization pipeline, directly from the Hugging Face where this model has been deployed, and there are some inference APIs also. You can use that if you want. So we are going to see how we can leverage this language model to build this application in Streamlit. And in upcoming video, I'll also create an API using Fast API for the same, and we can also have a web app there with maybe Fast API and React, for example, to build this kind of an application. So in today's video, we will focus on LaMini Flan T5, and we'll build this application using Streamlit. So if you see currently, I am on their Hugging Face repository. Okay, it's by MBZUAI, which is a university in United Arab Emirates. If you see here, Mohammed bin Zayed University of Artificial Intelligence. This university has great potential, because when I'm currently also pursuing masters in AI, and when I was looking to different universities where I can pursue my masters, I also shortlisted this university. It has great potential because kind of the research facility that they have, and the faculties who are teaching it in this university. Okay, so if you come down, you'll see all the faculties, their programs. So they have master's program in, I guess, in all the subset of AI, like deep learning, natural language processing, machine learning, and computer vision. So they have their master's program separately. If you want to pursue your masters, you can maybe consider this university as well. If you see, they have computer vision, machine learning, natural language processing, etc. Okay, and they are doing good, and they have a PhD program as well. They have faculties, their research, and they're still taking admission for at least UAE nationals. And if you're outside Emirates, you may need some entrance exam that you have to clear, for example GMAT or GRE, etc., that you have to clear. And so they have developed this, fine-tuned this model. Okay, and if you come over here, Mohammed bin Zayed University of Artificial Intelligence, which is a university, their spaces on Hugging Face. If you see their organization card, they have multiple models here. They have around 22 models. Most of their models are based on LaMini. Okay, so if you see LaMini Cerebrus 256, they have multiple LaMini model. Okay, so we are using this one, LaMini Flan T5 248. If you come over here, it says a diverse herd of distilled models from large scale instructions. Okay, so this is the model. So that contains 2.58 samples for instruction fine tuning. So you can go ahead and read their paper as well. They have data set that contains these amount of samples, and their base model. Okay, so this Flan T5 is the base model where they have fine-tuned on the LaMini-LM series, and we are using this 248, okay, which is not that large, but gets the job done, guys. Okay, it's one of the how should I put it, crucial model when it comes to having a less than 500 M parameters, but it still works. Okay, and it's easy to set up on a local CPU machine as well. That's what we are going to try in this video. We are going to use our CPU machine to create this application. Okay, so if you see, they have given you some code basis as well, but we will not rely on this. Okay, these are there. So as I said, right, they have text to text generation pipeline and they have summarization pipeline as well. So we are going to use the summarization pipeline in this video. But if you want to maybe create a local GPT or private GPT, people are talking about that in industry. Currently, you'll see multiple videos on people are using private GPT, local GPT, mini GPT, etc., which are again based on Vicuna and Alpaca or Llama models mainly, and they are difficult to set up on a CPU machine. It works, hallucinates a lot. Okay, but hallucination is a problem with language model, guys. So let's see how we are going to build this application. So what you have to do first, what I have done in my case, you can either load the model from Hugging Face, okay, or you can download this complete folder, that files and version that you see. You can create a folder called LaMini-Flan T5248 and you can download all these files and keep it locally in your CPU machine. So if you see, I have it over here. So you can see this is a folder LaMini-Flan. This is the model name, by the way. Okay, the checkpoint. Okay, so this is called the checkpoint when we have worked with Hugging Face model. So this is a checkpoint and all the files are inside it. I have downloaded it. So everything remains private. Nothing goes outside of your environment. Okay, and you don't have to rely on internet as well. Once you download all these things for the first time, you need git lfs large files. Okay, so there's something called git lfs to basically clone this completely. You can do that as well. So if you come over here, you can see all the details. If you want to use it Hugging Face to deploy your models, you can also deploy that and all. Okay, so let's do that. Okay, so if you come in this folder, I have a folder called LLM Summarization. Okay, it's not that large, but it's still a language model. Okay, and then in data I have couple of files, okay, that I want to summarize. So I have some document, okay, that I would like to summarize. Let me show you that document, guys. So these are the document that we're going to use. Okay, this is one document, this is other. I have downloaded, basically I have created this, okay, from McKinsey website. I have taken the article and created a PDF file there to summarize. So we'll use Langchain, okay, to perform the heavy lifting for us. File loader, preprocessing, etc. will be done by Langchain, and then we will have LaMini-Flan T5248 to summarize that. Okay, we are going to use the pipeline of summarization. So let me do one thing. Let me just do a code dot here. So what I will do, I'll open that in VS Code, and now you can see I have opened that in VS Code. And the first thing is that these are the requirements that you need. So you need Langchain, you need sentence transformers, torch, sentence piece, accelerate are the dependencies. Okay, I have also kept ChromaDB because I'm also creating one more video. As I said, one more video will be created with a text generation pipeline. So for that we need embeddings, vector embeddings, and that's why we'll use ChromaDB there. The other video that we are going to create very soon. And then we have PyPDF, tick token, Streamlit, etc. These are the requirements. Okay, you do not need fast API, UVCon, Python multipart, and AIO files for this video. Okay, for particularly this video, but I'm going to use the same environment when I'm creating the fast API based API and application, as I said in the beginning of this video. So I have created a single environment and I have installed everything into it. Okay, so this is the thing that you need. And I have LaMini-Flan T5248 million, and I have a data where I've saved this data, by the way. Okay, so let me just do one thing. Let me create a file called not inside data here. Okay, so what I'll do, I'll create a file called app.py. So in app.py here, okay, we'll start writing the code, guys. So what are the things we need? So we need Langchain, we need torch transformers, who are the backend engine. Okay, so for LaMini-Flan T5248M. So let's first import. So the first thing that I'm going to import is Streamlit as ST. If you are not familiar with Streamlit, it's a web framework, okay, which help you create data science app faster. Okay, so it's very simple. You don't need any web technologies expertise and all. Okay, so import Streamlit as ST. Now the thing that I need is from Langchain.text splitter. We are going to split the text in the document. So text splitter import, and I'm going to use recursive text character text splitter. Okay, pretty much straightforward. Langchain documentation is one of the best documentation I have ever seen, guys. In my development career of 6-7 years. Okay, Langchain has the best documentation out there, and they are growing so fast. I think one of the most used library this year. Okay, that's how I know. I this is my guess that this library has been the most used. Okay, in the recent times. So what we are doing, we are going to use recursive character text splitter. Okay, from the Langchain.text splitter. Okay, so you need some chunk overlap. You need the chunk size, etc. Okay, we'll keep a smaller chunk size just to do it faster. And then we need document loader because we are going to use a PDF file in this case. You can again work with, you can extend this further with, with for Word document, for TXT file, etc., JSON, etc. as well. Okay, so from Langchain.document loaders, import, we need PyPDF loader. Let's have PyPDF loader, and then we need directory loader. Document loaders. Yeah, this looks nice. And the next thing we need is, so let's have a chain. So Langchain dot chains dot, I need the summarize chain. Okay, so you can see this summarize chain. It has multiple chain, question, answer, retrieval, conversational. It has a multiple chain. You can use that. Okay, so from Langchain dot chains dot summarize, import load summarize chain. Okay, if you want to know more about chain, you do not have to go anywhere. You have to go to Langchain documentation. As I said, right, they have covered everything. Just go on Langchain docs. In the left hand side, you will have, let me just show you also what I'm talking about. So just write Langchain documentation. Go to Langchain documentation. Welcome to Langchain, and you will see in the left hand side you have everything. You do not have to go and watch videos, etc., etc. Okay, it has everything that you need. Okay, so if you come on chains, you will see in the chains that you will find chains. In models, you will find models, LLMs. Click on LLMs, you will see everything that you need, guys. Okay, so if you summarization, so come on summarization. You see I'm using this load summarize chain. As I said, right, they have chain type, map, reduce, stuff. They have every different type of chain type as well. So just go through the documentation. It will help you learn faster. Okay, now so from Langchain.chains.summarize is done. We move to transformer thingy. Okay, so from transformers, import, we need T5 tokenizer. Okay, we need tokenizer, and the way we are going to load the tokenizer and model. So we'll use conditional generation for model, and we'll use T5 tokenizer because we are using Flan T5. So T5 tokenizer, let me write, from transformers, import T5 tokenizer and T5 for conditional generation. I don't know why it's not auto suggesting me, but it's okay. T5 for conditional. I think I have spelled this wrong. Conditional. Okay, this looks good. So from transformers, import T5 tokenizer, T5 for conditional generation. Now from transformers, import, let's have pipeline, where we are going to use the pipeline of summarization pipeline. Okay, of LaMini model. And then torch, without torch, because we are going to use the float, that we are going to define the floating point if required. Okay, so import torch, and then we need import, I don't know, so let's keep base 64. The reason I am using base 64, I'll tell you, because on Streamlit we are going to have a PDF viewer where we'll show the PDF. Okay, display the PDF basically. So for that we need base 64, for that file encoding, etc. So for import base 64 is done. The first thing that we need, guys is to load the model and tokenizer. So we have to define the checkpoint. So model and tokenizer. So for that, let's first define our checkpoint, because we have downloaded the model locally, model files, weights, everything locally, because we don't want to rely on internet. Even anyway, it doesn't require internet, because it's, when you run for the first time through Hugging Face, it stores in the local cache. But it's better to have it download it locally because it's not that big. Okay, so you can do that. So checkpoint, and in this checkpoint, what I'm going to do, I'm going to define this. Okay, I do not need this LaMini Flan, your folder name where you have kept the model. Okay, so model name, and you can see PyTorch model.bin, which is the important file here. Okay, the model weights, and that's what you need. So our checkpoint is defined. So let's have a variable called tokenizer. So in this tokenizer, we'll use T5 tokenizer from pre-trained. Pretty much straightforward if you have worked with Hugging Face models. So from pre-trained, we are saying, okay, go to T5 tokenizer module or class, and from pre-trained load that. So checkpoint, and then we have base model. So in base model, what I'm going to do here, in base model, I'm going to say T5 for conditional generation and from pre-train. So let's do that from pre-train. The first thing is checkpoint. Where is your model? Basically where you have kept your model. So if you have kept it locally, because we have this checkpoint. If you are trying to load it from Hugging Face, you have to give that repository name. Okay, like MBZUAI / LaMini, whatever it is. Okay, checkpoint. And then we need device map. Couple of parameters here. Device map equals auto. Device map equal auto, and then we have torch d type. So torch d type equals torch.float32. So this is done. Torch.float32. If you don't know what is device map, so device map basically helps you to inference with bigger models. Okay, so we have a model size which is too big. Okay, so basically it has CUDA, it has CPU, it has auto. Okay, it has different way of inferencing this model. It's adjust it automatically. So we have device map auto. It will automatically shuffle it between your, if you have CUDA enabled, you can use CUDA there. If you have CPU, if you only want to rely on CPU, you can also use CPU. So maybe you can read more about device map on the Hugging Face documentation. So what we are doing here, guys, we have tokenizer. So from tokenizer, we are saying T5 tokenizer dot from pre-trained. We are loading the model from tokenizer from this LaMini Flan T5 248, and then we have this base model from conditional generation from pre-trained. Device map auto, torch d type, torch float 32. So there are different, you will see the data types that we are loading the model, and we are this based on the tensors value. Okay, so you would have heard about 4-bit quantized, 5-bit quantized model. You have different types of models there, way of loading model that will help you run on CPU as well. So we are relying on float 32 for the tensors. So torch.float32. So our model is done, tokenizer is done. Okay, we have loaded it successfully. Now what we need is we need something that will load the file and will perform the pre-processing. Okay, we have to split the text. Okay, and that's what we are going to do. So we are going to rely on Langchain for that. So I'm not going to write that function because I already have used in many of my previous videos. Okay, so I'm just going to take it from my gist. You can see I already have it here, pdf loader.py. So I'm just going to copy this. Okay, if you want to use that, you can also, I can share this link in the description, but I have used the same function in some of my previous videos. You can go ahead and look at it as well. So what I'm doing here, I have a function called file preprocessing, which is taking file as an input file. That will be a PDF file, and we are using a pipe PDF loader class from Langchain. Okay, the document loader, and we are using the load and split function that loads it and split it. And then we have chunk size of 200, which we have a small chunk size here because that we want to run it a little faster. We have chunk size 200. You can play around these numbers. Okay, chunk size, chunk overlap, etc. And then we are splitting the document because there might be number of pages stuff. And then we have final text. We have a final text which is an empty string at this moment because we only need the text. So from text in text, you can see final text equal to final text plus text.page content. We only need the content, page content. Okay, and we also need spaces in between, so it takes care of it. So we are returning the final text. Okay, so we're going to use this function. Okay, and that is completely based on Langchain. It helps you do the heavy lifting kind of stuff. If you don't want to use Langchain, you can use PyPDF2 or PDF Plumber, etc., etc. There are other libraries to work with the PDF files. So I basically go with Langchain because it's easy to use. It does the heavy lifting for you. Okay, now we are done with this. Now here we have to write the LM pipeline, guys. Okay, the language model pipeline. Okay, so let's write it. So I'm just going to define a function called define LLM pipeline. Define LLM pipeline, and in this I'm just gonna do a file path or something. Okay, define LLM pipeline, and here we're gonna write some function here. So define, let me check. Okay, define LLM pipeline. Just a minute. Okay, file path, and so let's create the pipeline, guys. So pipeline, as I said, right, it has two pipeline. Okay, one is the summarization and the other is text generation. So in pipesum, we are going to define the pipeline. So in pipeline, okay, just a minute, pipesum equals pipeline and in this pipeline we are going to write all our arguments that are required, okay, the args. So pipeline, the first thing that we are going to use is summarization pipeline. So we'll just write summarization. It also has a text generation pipeline, as you can see that on Hugging Face repository as well. So the first pipeline that we are going to use is summarization. Okay, if you want to use this model for text generation, you can please try that as well. Okay, you can use some vector databases for embeddings. You can store your embeddings, and then you can use inside this pipeline, you can pass embeddings and LLM, okay, in the chain of Langchain. Okay, question answer retrieval or conversational or whatever chain that you are using. So here we are using the summarization. Our model is nothing but our model is base model. So model equals base underscore model. Model is done. Then the next thing is tokenizer. So tokenizer will be tokenizer. Tokenizer equals to tokenizer, and then a maximum length. Okay, so let's keep it 500. Maximum length that we are returning is 500 and minimum length is 50. You can again change this number if you want. So minimum length is 50. So we are done with this. So we have defined our pipeline. Okay, so we have a variable called pipe sum, pipe underscore sum, which uses a pipeline class, okay, from transformers, and then it uses a pipeline from LaMini model, which is summarization, and then we are defining the model, tokenizer, maximum length, minimum length. You can use multiple other arguments if you want to use that. Okay, there are multiple parameters there. Okay, so maximum length, minimum length. Okay, now the next thing that we do is, so let's have a variable called input text, and in this input text we are going to use that function, file preprocessing function, and just we're going to use the file path over here. This function that we are using here, because that loads the file, does the pre-processing, returns the final text. Now that being stored in input text. Now we have input text, we'll have result, and in result we'll use this, pipe sum. So result, and let's use pipe sum. Excuse me. And in this pipe sum, what we're gonna do is we're gonna pass the input text, and we only need the summary text. Okay, so we have to basically extract the value summary text. So what we're going to do here, okay, I'm just going to write again result equals result, the first one, and then the summary text, because this is what LaMini model return, guys. So it returns with some metadata as well. So summary text, and then I'm just going to do return result. That's it. So what we have done in this function, so we have LLM pipeline function where we are passing the file. Pipe sum, we have a variable where we are defining the pipeline using the summarization pipeline, passing the model tokenizer, defining the parameters of maximum length and minimum length, and then we are using the function that we have written above, file preprocessing, and again we are getting the result and extracting only the summary text. We do not need other details, like maybe some other details like, for example, number of K, etc. We don't need that. We only need summary text. Okay. Now, what we're gonna do is write the Streamlit code. Okay, so let's write that. So the first thing that we're gonna do here, let me just write Streamlit code. So one more thing we need, one more function we need, because we are going to display the uploaded PDF file. So we'll have a file uploader PDF, and we also want to show that PDF file. So for that, let's have, I have also used in my previous function, you can see this function, display PDF file. It helps you display PDF files on a Streamlit application. So I'm not writing the code, it's also given on the Streamlit community in the discussion forum. So what we are doing here, we have, we are using cache data. Okay, so there are two different types of cache decorators available in Streamlit. So cache data and cache resource. Okay, so in cache resources, if you are dealing with NumPy operations or models, etc., you can use that cache. You don't have to, it's stored in the cache. Okay, you don't have to load it every time. And when we're doing cache underscore data, it's for your CSV file, JSON file, etc. files that you have. Okay, so that's what we are using. So we are having a display PDF file, passing the file, reading it, base64 encoding. Okay, then we are embedding PDF in HTML, because on the Streamlit UI we are going to show. So we are doing the iframe. Okay, passing this base64 PDF which contains the PDF base64, and we are defining width and height. and just using markdown because Streamlit supports markdown. Okay, so displaying the file over there. Now let's write the Streamlit code, guys. So the first thing that I always do when I write Streamlit application, create Streamlit application, is defining the layout. I need a wide layout. So the first thing that you should do is the set the page configuration. So set page config, and in this case it's layout equals wide. So let's do that. So layout equals wide. This looks good. And then what I'm going to do here, I'm going to write a main function, and inside this let me just do a pass for now. Let me come down, if name underscore underscore. Okay, now here we will write our Streamlit code, which is pretty much straightforward. So define main. Okay, and the first thing that we need is, let's have some title and all. So SEO title, and here we will write document, for example, anything. Let's give a name of this app, document summarization, app using language model or something. Okay, this looks good. Okay, so this is the title, and maybe here also we have a parameter called page title. Okay, so in page title we can write summary app or summarization app, something like this, summarization app. So this title looks good. Okay, we have SEO title. Now we need one thing. With the first thing that we need is uploaded file. And in this uploaded file, what we're gonna do, we're gonna use the file uploader function. So htfile_uploader, streamlit.fileuploader. Give a label to that and say upload your PDF file or something. Upload your PDF file, and then let's define an extension type that only PDF is allowed. Okay, this is done. So we have uploaded a file, ht.fileuploader. Now what we're going to do here, okay, we are going to check if there's a value inside it. So if uploaded file is not none, we're going to say, let's have a button now. So if uploaded file is not none, if ht.button, and then we'll have summarize button. When you click on the summarize button, the next set of code should get executed. So if ht.button summarize, and here we'll have two columns, guys. So let's have two columns. So the first is column 1, column 2, and we're gonna say ht.columns. We're gonna divide the layout into two parts, column 1, column 2, ht.columns 2, and with column 1, so everything that goes inside column 1, let's have a info. I'm just gonna say uploaded PDF file, something like this. Let's have a column 2 also, and let's run the app now. So with column 2, I'll say ht.success or not success. Let's have info, and let's call it summarization is below or something. Summarizing PDF file, or let's say summarization is complete. For now, let's have summarization is below or something. Okay. Now let's run this, guys. So we have, at least we have written the code for the template. Okay, where we are going to have two columns. In column 1, we are going to show the uploaded PDF file, and in column 2, summarization that we are going to show. Okay, so let's see how we're going to run this. So I'm just going to say, hey Streamlit, run app.py. Okay, I have to activate the virtual environment. So cd venv cd scripts /activate on PowerShell, and cd dot let me do a clear, and then I'm gonna just use the arrow command to get that Streamlit run app.py. It says cannot import name T5 tokenizer from transformer. Okay, so this is the error that we are getting, cannot import name T5 tokenizer. Okay, I think I have done something wrong in the import. This should be caps, T5 tokenizer, T5 for conditional generation. This looks nice. So T5 tokenizer, conditional, this is okay. Now let's go back. Let me just save it, Control S, come back here, rerun. It will take little time on the first time. If you're running it for the first time, it takes little time. So now if you see document summarization app using language model, this is the UI that we have got, guys. Okay, so now here you can do one thing. You can upload a file up to 200 MB, okay, your PDF file. I'm going to upload a PDF here, okay. So if you come on desktop, I'm going to use this document or maybe document 1 for now. Once you click on document 1 PDF, it will show you the summarize button, okay. Once you click on summarize button, it will use Langchain function that we have written for pre-processing, and once the pre-processing steps are done, when you have the final text, that you pass it to LaMini-LM model, and then LaMini-LM model will utilize the summarization pipeline to return you the summary for this PDF file, okay. Let's click on summarize. Okay, so now we are not seeing it because we haven't completed the code yet. So you see that we have two columns, uploaded PDF file and summarization is below. So in this uploaded PDF file, we'll have the PDF, we'll show the PDF, okay, the PDF will be displayed, and in the summarization we'll write the summarization function, we'll utilize the summarization function and we'll return the summarization. If you come down, let's write it over here. So here in ht.info uploaded file, okay, what I'm going to do in this case is, let's define that. I'm just thinking, where should we define we need a file path, so let's define that on top because we need it for both the columns. So here we'll define maybe file path, and in file path we have our data folder. You can see this data folder. So in this data folder, so data, and in this data let's have maybe data plus and our uploaded file and dot name. We need uploaded file dot name, the name of that file, and we store this here in the data, and that's what our file path now contains. And we can use file path in both the columns, column 1 basically to display that, and column 2 as well. So that let's see that. Okay, so now with column 1, or so now what we are doing, we are storing that file here in the data file. So let's do one thing, okay. We also have to use open here to read that. So with open, okay, right, so file path, so let's write that in the data folder. So as maybe as a temp file, so I'm just going to do as temp file, and then we're going to say temp file dot write. We are writing it, and then we read uploaded file dot read. I think it's read the Streamlit. So read, and this should do, okay, temp file dot write, uploaded file dot read. So content, okay, this looks good. So now in column 1, so in column 1 what we're gonna do here, guys, we're gonna just say, okay, temp file dot read, or let's have define a variable called PDF viewer, okay. So PDF viewer, and in this PDF viewer you're gonna use the function, okay, the function that we have, display PDF. So display PDF, and in display PDF what we're gonna pass here is we're gonna pass the file path which stores our that inside data, the data folder that we have, the file. So here I'm gonna do file path. So this looks okay. Now let's come and see if we are getting the able to show the that PDF. Okay, so let's run this. Now you can see we are able to show the PDF file, okay, on the UI. So this is the PDF file that the end user has uploaded. Now what we're going to do here is to use the other function that we have written, LLM pipeline or LLM summarization, and we are going to return the summarization for this particular file using that language model, okay, which is completely open source. We are not relying on OpenAI and all those, you know, commercial or paid models there, okay. So ht.info, here we're going to use the summarization. So let's do that. So let's have a variable called summary, and where we are going to use the functions. The function name is what? LLM pipeline, yes. And in LLM pipeline we are passing the file path. This is okay. So let's have ht.success, and in ht.success we're just gonna pass the summary here. So just gonna write summary. Okay, this looks good. So what we have done in this both the columns, guys, in the column 1, you know, we are displaying the PDF. In column 2 we are returning the summary. We are using this function called LLM pipeline, okay, and we are returning it. So now let's run this. Now again I will click on summarize, and it will take little time to summarize it because I'm on CPU machine. It might take up to 30 seconds to 45 seconds, you know, for this single file. You can have multiple pages as well. So let's do that. You can see it says it's running. Okay, so when you see running, okay, it means the on the Streamlit UI, when you see running, basically it's in the backend, it's processing your file or whatever operation that you have. Now you can see we have received our summary. Summarization is below. Such a, looks beautiful. Okay, isn't it? It says generative artificial intelligence has become a significant. You can see it has emerged here, as emerged as a remarkable advancement. It's also doing the little bit of paraphrasing as well. It's not actually returning the, mainly the same thing. Okay, so you would have studied about abstractive and extractive summarization. Okay, if you have worked with summarization, you can see it's very important to understand the abstract behind the text that you have. Okay, and that's the better summary. So you can see if you read this, generative artificial intelligence has emerged as a remarkable advancement, but here it says a significant advancement in machine learning, blah blah, this capability. And I can also see that, right, this capability, if you see this, these models then generate, but here it doesn't say that. Okay, it says generating new content. So it's also doing the paraphrasing for you. It gives you a summarization. We have here 2 paragraphs, here we have 1 paragraph. We return the summary. Okay, and you can see that summarization is below. Fantastic, right? So we have one more file. Let's see that for as well. So what I'm going to do here, I'm just going to use this AI blog, a blog that I have downloaded from internet. I've created a PDF file, and now what I will do, I'll click on summarize. So once you click on summarize, okay, it says, you can see it says cannot copy out of metadata. Okay, so what I'm just, I think, let me just do one thing. Let me just do a control C. Let me just run it again. Sometimes it might stuck. Okay, it might take complete memory that you have, okay, of your system. Okay, it might crashes also, because most of the time when I am uploading PDF files which are basically having multiple pages, it can also crashes your system. Okay, that's the problem with when you are running it locally. Now let's do one thing. Let's run this AI blog PDF. And if you want to do it for other kind of file formats like docs, text, JSON, you can also do that, guys. Okay, so the code will be available on the GitHub repository, AI Anytime GitHub repository. You can go and you can get the same, maybe LaMini-LM Summarization app or something. Now you can see this is the file that I've uploaded, and it has multiple paragraphs, and it's about AI and automation. And you can see that AI and automation are becoming the need of the hour as advancement in technology is growing day by day. Okay, so AI has solved. Okay, and you can see here AI has been solving various problems, but here we have got AI has solved problems. So it means it paraphrases as well, guys. Okay, so it understands the abstract behind it. Okay, it's not only extracting the sentences from middle or somewhere and it concatenating it or merging it. Okay, it understands the abstract, and that's the beauty of language model. Okay, and that's the beauty of Lamini language model. Okay, you can run it on CPU. You can see that how we build a Streamlit application that can summarize your document, PDF, doc, etc. You can also extend this further. Let me know if you are extending it further. I'll be more than happy to also collaborate if you are thinking of something on this kind of application. And I did it live. Okay, there is no edits and all in this. We also solved some of the errors also where we got some errors, but this code will be available. Okay, let me just give you a walkthrough what we are doing. We have imported all the libraries. We have model and tokenizer. Okay, so we have downloaded all the files, have this folder, model, the same model name, Lamini Flan T5248 million parameters. We have tokenizer and base model. Then we have a Langchain doing the heavy lifting, file loader and pre-processing, returning the final text, passing that final text to the LLM model, Lamini model. Okay, and then we have summarization model, tokenizer, etc., etc. And then we have a Streamlit app to utilizing those functions and showing the result. Okay, that's what we have done in this video, guys. And you can see the result in front of your eyes here on the screen. Looks great. You can extend this further. You can perform topic modeling on this summary if you want to find out which topic this article belongs to. Have a video for that as well. You can extend it further, guys. Okay, and you can also utilize text generation pipeline of Lamini. Okay, here we have utilized the summarization pipeline, and I'm also releasing that video very soon. Okay, so in the upcoming video, what we will do, we'll use Fast API to create an API and also a web application for the same. That looks a little better, guys. Okay, to be honest, and that's all. That's all I wanted to do in this video. I wanted to show you Okay, and it's a very niche area currently, the language models or the large language models we are calling it, but the underlying concept remain the same. If for text generation you need some kind of embeddings, it's not necessarily mean that you need, but vector databases has many advantages. It has default similarity search, default search, it is faster to retrieve the embeddings, etc. So if you are trying to create some kind of text generation chatbot conversational AI, please use vector embeddings, so vector databases like ChromaDB, FAST, Elasticsearch, etc. Okay, and so that's all for today's video, guys. I hope you liked the video. Okay, and if you like the content I am creating, okay, I always want to create projects, project powered by LLM or the recent trends that we are seeing, not only covering the what's really happening, this model or that model has been released. There are multiple videos like that. Okay, my main focus is to create project based videos that you can create some project using these models or technologies that we are currently seeing. So if you like the content, please hit the like icon. Okay, if you haven't subscribed the channel yet, please do subscribe and share this video with your friends and to peer. Okay, thank you so much for watching, guys. See you in the next one.